unfortunately, I cannot talk about risk analysis or this topic. I told Coleman that I only can introduce our CCS demonstration project in Japan. But I try to, as a summary, I try to put some two slides at the end of my presentation. So my topic is, at first, I will introduce about the outline of Tomakomai project. Tomakomai is the name of the city in Hokkaido Island in Japan. And also, in terms of the risk assessment, I understand the appropriate site selection is very important. So I will talk about the investigation work, survey work at the Tomakomai site before selecting the Tomakomai site. And also I will introduce CO2 injection system and the monitoring system. And secondly, the monitoring is very important in terms of risk assessment. And also, risk matter. And also, I will introduce the schedule of EPC. At this moment, we are in preparation period of CCS project in Japan. So that I will introduce the schedule. And also, I put the word information disclosure. But okay, this is the public perception or public outreach. I put one slide here. We are doing very interesting work in Tomakomai city. And as I said, as a result, as a conclusion, I put two slides about managing risk. At first, I'd like to introduce my company. Our company is established in 2008, which is just before the G815 summit. And we know that in the summit, CCS will be the major topic. So at that time, one of the ministry, economy, the trade and the industry wanted to have a CCS demonstration project after the successful pilot injection test by Light in about the city. So I'd like to emphasize that our shareholders is 35 Japanese companies, including all electronic power companies, also 5 engineering, 5 petroleum, and 3 petroleum resource development companies. And our shareholders is 5 companies. And at this moment, our president is from Japan, what we call the Japan Petroleum Exploration Company. And also, I used to be a petroleum geologist of this company, and at this moment, I'm working for this Japan CCS. At this moment, we have about 50 staff, almost from shareholder and shareholders. And the right-hand side, actually this demonstration project is being conducted by the government. And the government assigned us to carry out this project on behalf of the government. So our shareholders invest us to some amount of the money, but this money is only for the cover running cost for the implementing this demonstration project. And the government, Japanese government, they are the 100% cost of this demonstration project. So I used to call this one Japan model, but this is our system of this is demonstration project in Japan. And this is a pro scheme of the CCS demonstration project. So the CO2 source is our petroleum refinery in Hokkaido Island. So we are planning to get the carbon dioxide amount is 100,000 tons, more than 100,000 tons per year. So that is the reason that GCCSI is, there is no Tomakomai project in GCCSI map. So that our carbon dioxide amount is slightly less than the criteria. And we are going to construct a capture facility just beside this refinery. And so the next, just this capturing facility, we are going to construct a compression facility. Also, we are going to drill 2 injection wells. There are two reservoirs. One is called Moebius Formation, which depth is between 1,000 and 1,200 meters. This is the sandstone. And the other reservoir is Tomakomai Formation, and the depth is between 2,400 and 3,000 meters, and consists of volcanic plastic rocks. So we are planning to inject these 2 reservoirs. So we started investigation work from 2008 to 2011, and then right now from 2012 we are in preparation work to 2015, and hopefully from 2016 we start injection of carbon dioxide. At this moment, the plan is for 3 years we are going to inject carbon dioxide more than 100,000 pounds per year. And after the completion of the injection, we will monitor after injection period, we will monitor carbon dioxide behavior. And government, plan of the government is after 2020, they plan to commercialize this CCS system in Japan. So at this moment, as a preparation, there are actually 4 categories. One is construction of onshore facilities, this left-hand side. So as I said, we construct the capture facilities. And the second one is drilling 2 injection wells. So actually this coming summer, from July, we start construction of this capture facility, and then at the same time we started drilling 2 injection wells. Also, we have to check the regulation and the standard for the safety, review the existing rules and regulations for the CCS in the commercialization stage. And also, after completing this construction, someone is at the same time of construction, we are taking a monitoring baseline monitoring data during this period. So the purpose and task of the demonstration project is written in here. It's very busy, but top of the list I put the demonstration of the purpose is to demonstrate overall system from capture to storage, the integrated system, and also we want to confirm existing technologies. Some people already mentioned that the technology, elementary technologies, already exist. So we have to confirm these technologies work properly and efficiently. So also the same thing, but the third one is that we also have to demonstrate this system is safe and reliable, and also confirm the effectiveness of site selection guideline, which is established by the METI, and in order to demonstrate no leakage. Also, we have to clear anxiety about earthquakes by CCS, carbon dioxide injection. But there are 2 phases actually, and one is no influence by natural earthquakes on CO2 stored, and also the not as perceptible earth tremor. I would say earth tremor, not earthquake by CO2 injection. And also, we have to confirm guidelines for geologic models to give and to improve. We have to improve this model, and also we have to prepare technical standards for operations and safety for the future project. And also, we have to disclose project information and also data and assist citizens in understanding of CCS. So finally, to clarify various tests to be improved or solved toward commercialization after 2020. At first, I said that I'd like to introduce what we have done in survey stage between 2009 and 2011 at the Tomakomai site. There are many existing geological data already from 1970s. The company and the government did survey for the petroleum and natural gas exploration. So we borrowed this data and did preliminary geological study over this area. But still there is not enough data. So we have taken the 3D seismic survey data over the narrow area. Also we drilled survey wells. We drilled 2 survey wells. Using these information, we did reservoir simulations. We constructed geological model, and we did numerical model to predict carbon dioxide behavior in reservoir. So finally, we made this kind of geological evaluation report, and we presented to the government. And at the same time, we did the conceptual designing works. So from capture and transportation and the injection system, and also we made a monitoring system, and we put them together to this basic plan of CCS demonstration project. So we presented to the government, and government decided to conduct CCS demonstration project in this city. So the Tomakomai city is this is Tokyo and Tomakomai. This is the Hokkaido Island, you may know. The Tomakomai city in here, about the distance from Tokyo is about 800 kilometers, and it's located just around here. In this between 2009 and 2011, we did, as I said, we did seismic survey at first, very small, 3 kilometers, very small seismic survey. And we confirmed, not really confirmed, but we confirmed the presence of the reservoir. And then next year we extended the 3D seismic area in this side. And at the same time, we drilled this survey well from coastline to the subsea bed. And we constructed the geological model for the Takinobu Formation deeper reservoir in this extent, in this region. And at the same time, we made a model of geological model of Moebius Formation in this rectangular area. So this is one of the seismic cross-section in here. So at this moment, we are planning to inject carbon dioxide somewhere around here in the Moebius Formation, and also in the Takinobu Formation. So as you see, there is a fault, old fault here for the Takinobu Formation, but we confirmed from shallow characteristics this is not active fault. And this is cross-section of the southern well for the Takinobu Formation. As I said, the well heading in a coastline, almost coastline, and we drilled to the subsea bed. The drill depth is 3,700 meters and vertical depth is 3,000 meters. So we have taken many core samples from cap rock to the reservoir. And also, at this well, we cannot take any core samples in a shallow reservoir. So we drilled just after this well, using this smaller well, we drilled down to 1,200 meters and take some core samples from the cap rock and also reservoir rock, and we did many core analysis to get many reservoir data. So after making a geological model, we did this kind of numerical simulation. This is plan view and this is cross section, and this is for the Tomakomai. Sorry, this is for the Moebius formation, shallow reservoir, and this model simulation was done by injecting 250,000 tons per year carbon dioxide for 3 years. So this picture is just completed the injection of carbon dioxide for 3 years. So as you see, the distribution of carbon dioxide is something like this, very close to the well. And this is in gaseous phase. I would say supercritical phase, carbon dioxide distribution. And this is dissolving formation, geological formation of water. So this is cross section. You say it's about several hundred meters the carbon dioxide will be distributed. And then we continue this simulation for after 20 years. It slightly expand its distribution and in horizontally and vertically as well. And that increased dissolved amount in formation of water. And after 20 years, actually we continuously calculate, but there is not much change in this picture. So I skip these interval, and this is after 1,000 years after completion of injection. So as you see, the distribution is not much different from the previous slide, but the dissolved amount of carbon dioxide increased slightly. So we stopped the simulation at this stage, and we confirmed that we cannot inject carbon dioxide safe and stable at least for the demonstration phase. So that one is a numerical modeling result for the Moebius formation, and actually this is the contour map of Moebius formation. As you may see, there is no closure, unplanned closure. It's dipping to the westward, and this is the location of the survey well, and this is the planned injection well. And the carbon dioxide distribution is somewhere around here. And the dip angle is about 3 degrees to the west. And on the other hand, this is Tomakomai formation. It makes this kind of unclined closure, which, as I explained, there is old fault in western rim of this antline. So we keep a distance, about 2 kilometers distance from this fault to the plant injection point. And this dip angle to this direction is about 15 degrees. But I didn't bring any detailed simulation result, but this reservoir is very similar. The result of the simulation is very similar. After 200 years, not 20 years, after 200 years, carbon dioxide stays somewhere around here. So we also confirmed that the Tomakomai formation is suitable for the CCS demonstration. So this is a cross-section of this area. Left-hand side is landward, and the right-hand side is seaward. So we are planning to build this kind of 2 injection wells from coast to the subsea bed. And this one is horizontal, and depth is, as I said, between 1,000 and 200 meters. So I think this is actually drilling of this well is very difficult compared to this well. This well is total depth is about less than 6,000 meters, but we are drilling in a consolidated cap rock, so we don't see any trouble during drilling of this well. But we may have some trouble because of unconsolidated Capital Reservoir in this well. So we have to be very careful about drilling these two wells. And this is the front view of injection monitoring system. The oil refinery is located here, and actually Tomakomai city center is here. In this larger district, 170,000 people living in this area, and the distance from city center to the injection point is about 5 or 6 kilometers. So it is very, very close to the populated area. And we are planning to construct capture facility just beside this oil refinery. And also, as I said, we drill two inclination wells. One is for the Miles Formation, shallow reservoir, and the other one is Takinoya Formation, river reservoir. The distance is about 3 kilometers from here to here, and about 4 kilometers from here to actually injection point over here. And for the monitoring, I think the most important monitoring is 3D seismic survey. We are going to use 3D seismic survey in the survey phase for the baseline. And during injection and also after injection, we are planning to take a 3D seismic survey over this area. And water depth in this area is about between 10 meters and 20 meters, about 30 meters and 40 meters. So it is very shallow. So conventional seismic boat we cannot take into this area. So that means 3D seismic survey is very expensive for the shallow marine survey. So between 3D seismic surveys, we are planning to take 2D seismic survey instead of 3D in somewhere around here. And also at the same time, actually, we laid an ocean bottom cable, which has more than 70 seismic seismometers in the cable. So we are planning to be the seismic data when we carry out the 3D seismic. At the same time, we are planning to get the seismic data. So we substitute two 3D seismic surveys using this 2D or identifying 2D seismic data. And many people are concerned about seismicity in this country, but also in Japan, some people are concerned about the relationship between injection and seismic. So as I said, we laid down this ocean bottom seismic cable. Also, we are planning to put ocean bottom seismometers in just above the injection point, also around the injection point, in order to get how to say seismic center we put this kind of seismic sensor. Also, we put. I said we drill this well for the third well, but we converted this well to the observation well. So we are planning to put a pressure, temperature, and seismic sensor in this well in this coming summer. And also we drill one vertical well. This well is for the Takinoya Formation deep reservoir. And we drill one observation well for the Miles Formation down to 1,200 meters. We also put the pressure, temperature, and seismic sensor in this well. Also, we drill one observation well far from here, about 8 kilometers from here to this side. We also put the pressure, temperature, and seismic sensor in this well. And also, we drill one shallow well, 200 meters well, for the detailed high sensitivity seismograph. Here, we put already, and we are getting data now before the drilling injecting carbon dioxide. So that so some people are concerned about seismicity, so we put these, we construct this kind of monitoring system, and we are preparing for to the answer during the injection. If some we will say the micro seismicity occur. And this is a schematic cross-section of monitoring system. As I said, we put the pressure sensor in these injection wells. And also, I didn't repeat in detail, but as I said, we put the temperature and pressure sensor and also the seismic sensor here, and here for the Tomakomai formation, and here for the Moyos formation. And also we put the observation ocean bottom seismometer in this place. So we get real-time monitoring data in monitoring house, and we observe before injection, also after, during the injection, and after injection. And also, actually, in case of Japan, carbon dioxide injection is permitted, will be permitted by the Ministry of Environment. So under the law of Marine Pollution and Maritime Disaster Act. So based on this act, we have to get the baseline data of the marine environment. So since last year, as you know, there is a fall season in Japan. So the last year we get the data summer, autumn, and winter. And right now, at this moment, we are collecting data in spring data. So that after collecting this data, we will do the marine environmental assessment in order to apply this injection pathway. And this is a schedule of current project up to 2015. So as I said, there are actually three parts. One is facility construction. At this moment, we are here. And yes, fiscal year in Japan starts from April. So now we are here from April to June. We are here. At this moment, we just started the preparation work for the site for the construction. And as I said, in July, we start construction of capture facility, and it will be completed in the third quarter of next year. And we will do the commissioning work for this capturing facility. And the injection wells, as I said, we are going to drill 2 injection wells up to the next year. And also we are constructing monitoring systems onshore and offshore as well. And the last 1 year, we are going to take baseline data. And from 2016, we are going to inject carbon dioxide for 3 years at this moment. And after the injection, after 3 years injection, then we will carry out 2 years monitoring for the after injection period. And I put information disclosure. Actually, this is public outreach activities. From the survey period, we did this kind of activities. We made panels in order to explain what is CCS. About 8 or 10 panels for explaining about what is CCS. Also, we made another additional 10 panels explaining about the CCS demonstration clarity in Tomakomai. So we did it since 2011. We did it 60 times in around Tomakomai city, panel exhibitions. And also we did small lecture meetings in university in Tomakomai City, also the high school in Tomakomai City, high schools in Tomakomai City, also the junior high school in Tomakomai City. We made this kind of small lecture meetings, and also every year we organize a CCS forum for the secretaries in this area. We did that 3 times already, and each time more than 200 people came to this forum, and I believe the understanding of CCS is improved every year. But unfortunately, this Tomakomai is the industrial city, but in outside of the Tokyo area. So for the CCS forum, there are many people older than 50s. So we did the inquiry in this forum, and the people attendees pointed out that we have to do some outreach activity for the younger people. So since last year, we did kids science rooms in local community, and each time more than 20 people come to enjoy this kind of science lectures. And also we welcome the site visit, and also in the Tokyo area there are 2 major environmental exhibitions. So we make a very big model to see what is the Tomakomai CCS demonstration. And so last year one is the biggest one, and the total participant is about 160, and 10% came to our booth to have a see what we are doing in CCS in Tomakomai City. So we are continuing these activities this year also, and I think we are trying to expand this kind of activity to the whole nations in Japan, but still CCS is not popular in Japan at this moment yet. And that's all. Actually, that's all about the CCS demonstration project. But I was told to include this kind of slide about managing risk. So this is actually my private opinion instead of company opinion. I think there are 2 phases of the risks. Some people already mentioned technical and non-technical. And the major technical risk is CO2 injectivity, some people already mentioned, and also the CO2 leakage. These 2 are major technical risks, I think. And I would put induced seismicity in a non-technical risk. I think technically we can manage this kind of risk, but in order to improve public perception, I think it is very, very important. So that I explained about monitoring system. I think this kind of monitoring system is very important to show about the induced seismicity, actually difference between induced seismicity and the natural earthquake. And so I think, as I said, I think CO2 leakage is very important. So I put this one here, and there are 3 sources of leakage. One is surface facility capture or compression facilities. Also, the one risk is from well bore, and the other one is reservoir. So I think these surface facilities just there's no special facilities for CCS. It's just conventional chemical plant. So just design and construction based on the existing standard and laws and regulations. And the well bore, actually there is no legal limitation for the grade of the well for the carbon dioxide injection. So we voluntarily construct these wells in accordance with the Mining Act and Mining Safety Act. And the reservoir, there is, as I explained, Marine Pollution Act in case of Japan. Also the METI, Ministry of Economy and Trade and Industry, made some kind of standard. So we have to follow these standards to select the site. And I'd like to emphasize that the appropriate site selection can greatly reduce the risk of CO2 leakage. So we have to carefully characterize the reservoir before deciding the demonstration project. And based on the detailed geological data, we made numerical, we did numerical modeling. So as I explained, the numerical modeling predict CO2 behavior in reservoir and also below the capital. And so as I explained, monitoring is also important in terms of the CO2 behavior. So we are planning to make detailed monitoring in this project. Also, based on this kind of numerical modeling and monitoring data, we will do the history matching during the injection or maybe after the injection and revise the geological model and then revise the numerical modeling to predict the CO2 behavior in a longer period for the safe and stable. So I think completing this kind of procedure in the CCS demonstration project, and we hope the understanding of CCS in Japan is much improved in order to implement, in order to commercialize CCS after 2020. Yeah, that's all from me, and thank you very much for your attention. I'm happy to answer your question.